What's up again, everybody? This is Mr. Harris bringing you some more math jewels today. And today we're going to be talking about arithmetic and geometric sequences. Now, in this first recording, the first video, we're just simply going to figure out how to identify whether a sequence is arithmetic or geometric, and then we're going to find a particular term in that sequence. So let's go ahead and get started with it. And so, first things first, we must know pretty much what is an arithmetic sequence. So an arithmetic sequence is basically a list of numbers or a sequence of numbers that have a common difference. So for example, if you're counting by fives, then 5, 10, 15, 20, 25, 30, and so on and so forth. That is the terms in this sequence have a common difference of 5. We're going to add 5 every term. Or in actuality, if I take the second term minus the first term, I'll get 5. If I take the third term minus the second term, I'll get 5. So another example of an arithmetic sequence is simply counting by twos. We can say 2, 4, 6, 8, 10, 12, 14, and so on and so forth. So there's just a pattern of numbers in this arithmetic sequence. Now, here you have the formula for finding any term in an arithmetic sequence, which we'll get to that in the examples below. So one of the things that I want to point out is that each one of these numbers is a term. Okay, so this is the first term. So we label that A1, A2, A3, A4, A5, and A6. So all this is saying is that this is the first term, this is the second term, this is the third term, fourth, fifth, and sixth terms. Now, if you notice in this formula, we say A sub n, and A sub n can be any number. So if I wanted to find the 100th term, I would just simply say A100. So that's an example of an arithmetic sequence. Now, when we go to a geometric sequence, they have a common ratio. So these are slightly different. So, for example, when we do these, the first term might be 1, 3, 9, 27, etc., etc. And if you notice, there's a pattern here as well. Okay? So, in this case, if I take 1 and multiply it by 3, I get 3. 3 times 3 is 9. 9 times 3 is 27. And we can find the next term by simply taking 27 and multiplying it by 3. Okay? So in this case, the next term would be, we can actually, let's go ahead and put it in there. It could be 81. We can put 81 there, and we can continue that pattern as well. Okay? Another example might be, let's stick with a simple one. Let's say 1, 2, 4, 8, 16. That's 5 terms. And then we continue that pattern. Notice in this first one, we're multiplying each term by 1. I'm sorry, we're multiplying each term by 3. And then here we're going to multiply each term by 2. So that is how a geometric sequence looks. Now, it's still the same thing in regards to the term. This is the first term. This is the second term. This is the third term, fourth term, and the fifth term. Okay? So now we're going to get into actually working with these sequences. So let's look at this first example. It says determine whether the sequence is arithmetic or geometric and find the 25th term. Now real quick, something that I want to point out is when I look at these formulas, the A sub n is just, n is the total number of terms, or any, I'm sorry, not the total number of terms, but it's any term. So whatever n is, if n is 4, we're talking about the fourth term. So that is very, very important. A lot of people confuse that. This D is that common difference. So we have to figure out what is the common difference. What are we doing to every term to get the next term? Over here on the geometric side, a sub n still represents the same thing. We refer to that as a sub n because n is a subscript. And r is the common ratio. So what are we doing to each term to get the next term? And here you have n minus 1, which is whatever the term number is. So let's go ahead and get here. Now, first of all, in order to determine whether it is arithmetic or geometric, we simply have to take each term and subtract the previous term in order to see if it's arithmetic. So if I take 16 minus 18, so I took a sub 3 minus a sub 2, and I'll get negative 2. And then I'm going to take a sub 2 minus a sub 1 just to see if that ratio is common. 18 minus 20, and that equals negative 2. So here we can say that D equals negative 2, and we can say, so since they have a common difference, this is going to be an arithmetic sequence, okay? And so this arithmetic sequence, what we're doing is every term you're going to subtract 2. Well, let's go ahead and take a sub 1 as well. A sub 1 is the first term in the sequence, which we see here is 20. So we've determined whether it's arithmetic or geometric. And in this case, let's write that over there. This one is arithmetic, okay? And that was a typo, arithmetic. All right. So then now, since it's arithmetic, we want to actually go ahead and figure out what is the value of the 25th term. So it looks like this. We'll say a sub 25. That's the 25th term in this sequence. And we need the first term here plus, in this case, n is 25 minus 1. And the common difference is negative 2. Okay? So if we continue on with that, let's go here plus 24 times negative 2. Now this is 24 times negative 2, not 24 minus 2. Please don't confuse that. So as a matter of fact, let's go ahead and put that in parentheses so we know to multiply first. So we have 20 minus 48, which in this case is negative 28. So that means the 25th term in this sequence is going to be negative 28. All right. So that's our first example. Let's go on to the next example. We're going to determine whether this is going to be geometric or arithmetic. So first thing we have is, let's say, A1, A2, A sub 3, A sub 4. So we just take, first of all, I'm going to take A sub 3 and I'm going to subtract it. So let's see, is it, so 4.5 minus 3. I always check to see if they're arithmetic first. And 4.5 minus 3 is 1.5. And then 3 minus 2, if we get the same thing, then this is arithmetic. Well, 3 minus 2 is 1. So since they don't have a common difference, we need to check to see if they have a common ratio. So we're going to say, we're going to take the same values, but we're going to say 4.5 over 3. And then we're going to say 3 over 2, okay? So here we get 1.5 and we get 1.5, or 3 over 2. It's up to you whether you use a fraction or a decimal. So they have a common ratio, okay? So in this case, we have R equals 1.5, and then A1 equals 2. So we know this is indeed a geometric sequence, okay? So geometric, okay? So since this is geometric sequence, in order to find the 25th term, we want to use this formula, okay? Now, when we use that formula, the interesting thing about it is we have to plug this in. So we're going to say A sub n equals the first term, which is 2, times 1.5 to the 25th 5 minus 1 term. And actually, I did not put my 25 in over here. So we need to put 25 here. So, boom. All right, so a sub 25 equals 2 times 1.5 to the 24th power. Now, 1.5 to the 24th power is a rather large number, but we can find it, okay? So, we're going to take that value and figure out what it is. And in this case, we get, let's see, a sub 25 is equal to 2 times 1.5 to the 24th power is approximately 16,834, and it's actually 0.1. Okay, so here when I take that value and multiply it times 2, I'll get 33,668 and 2/10. So that means the 25th term in this sequence is 33,668 and 2/10. So this is the beginning of how to identify whether a sequence is arithmetic or geometric. Hopefully this video will be some value for someone out there in the world.